What if I told you we have a product that can decrease America's demand for diesel fuel by 1.1 million gallons per day? That's about 1% of the daily diesel consumption in the US. Now, what if I told you you can invest in that product and have a 9x return? We are Thermal Conservation Technologies, and that is the impact and projected ROI of our product, Climate Control. The current insulation in refrigerated vehicles is energy inefficient, limits the amount of carrying capacity on trucks, and does not comply with new regulations on the trucking refrigeration unit. I'm Laura Klibanow, and these are my partners, Jacob Kist and James Parks, and today we're going to talk to you about how we plan to reduce America's dependency on foreign oil and lower the carbon footprint through the utilization of vacuum insulation panels. Thanks to research done at the University of Illinois at Chicago, our inventor, Dr. Alan Feinerman, has designed a new, high-performance vacuum insulation panel called Climate Control. It has higher insulative effectiveness and drastically reduces the cost of cold chain transportation. We at K&L Gates do both a patentability search and a freedom to operate search, and they concluded that our patent is both non-obvious, we have freedom to operate, and it is novel. So we have identified an opportunity in that there are 32,000 new refrigerated trucks produced every year in North America that can benefit from utilizing climate control. We will supply climate control to the manufacturers of refrigerated vehicles who can then sell their products which utilize climate control at a premium and qualify for the government's $2.3 billion in tax credits for clean energy and qualify for other incentives at both the state and federal level. Then, the purchasers of these vehicles will be willing to pay that premium because they will lower their operating costs by up to 50%, increase their carrying capacity on the trucks by up to 27%, and avoid those new regulations, those new regulatory fines on the trucking refrigeration unit associated with those high fuel emissions. So today we're going to take you through the path and how we plan to monetize this technology. We'll take you through the market context, the operations, and our financials. So, as I mentioned, Climate Control is a vacuum insulated panel. VIPs are highly effective thermal insulation technologies that are more effective than conventional foam or other fibrous materials because VIPs, like Climate Control, are not made of a material per se, but a vacuum. So there's virtually no molecules to pass heat between the two walls. Until now, VIPs have not been effective for most applications, including refrigerated trucking, because they simply have not been durable enough. Now, Climate Control is the first vacuum insulated panel that can be used in the trucking refrigeration market because it is made of stainless steel for panel strength and Kevlar for low thermal conductivity, making it lightweight and durable, so it is ideally suited for the trucking refrigeration market. So, as I mentioned, our customers are the manufacturers of the refrigerated vehicles. This is a $2.1 billion market in North America. 95% of that market is the refrigerated trailer. So as you can see in the picture, this is the compressor unit, which is pumping cool air into that insulated body. And here are our customers, how the market is segmented there. The other 5% of the market is the refrigerated straight truck. That's a smaller truck doing more localized deliveries. And here are our customers in that segment. I just want to point out that Frost & Sullivan did a study on this market, and they project that the actual demand for refrigerated trucks is in fact increasing. And some of the factors that they attribute to that growth is the current aging fleets and the consolidation of the agricultural industry. So specifically when we look at dairy, as huge dairy conglomerates acquire smaller companies, dairy becomes far less localized and there's a need for more refrigerated vehicles to distribute those products all over the US. Next, I want to take you through some technology drivers. I'll just highlight a few of them. Here in the state of California, CARB, the California Air and Resources Board, instituted new regulations on the fuel emissions specific to the trucking refrigeration unit. That refrigeration unit has its own fuel tank, and those regulations became effective December 31st, 2009. So now, at this point in time, any vehicle caught in the state of California that does not meet those new regulations will be fined between $500 to $1,000 per infraction, whether they're caught at a border crossing, a weigh-in station, or at a distribution center. So those companies have a choice. They can switch to a new technology like climate control, or they can pay indefinite amount of fines. Another thing I want to point out in terms of technology drivers is the high servicing costs in the compressor unit. So as I pointed out in the previous slide, the compressor unit is what's pumping the cool air into the insulated body. But if that body is not insulated properly, there's an increased strain on the compressor unit, which then increases the maintenance costs and the liability costs for the manufacturer of the compressor unit. With climate control, because it is such a high R value, with such a high insulative effectiveness, we can maintain that desired temperature inside the vehicle and then have the compressor unit actually turned off 50% of the time. So you're drastically reducing the maintenance costs on that compressor unit, lengthening its life, and then again lowering the liability costs on that company. So next I'm going to turn it over to my partner Jacob, and he's going to take you through the market context.
Thanks, Laura. So when we take a look at the insulation solutions in the marketplace today, polyurethane foam is the predominant insulation that is used. And if we compare polyurethane with vacuum insulation panels, VIPs, you can see that there's a compelling reason why they make good sense in this space. They lower operating costs and increase hauling capacity. Unfortunately, the VIPs in the marketplace today have been unable to penetrate this market because the durability of their exterior. Right now, they're covered with mylar, which is very easy to penetrate. Now, with climate control, we have a durable stainless steel exterior that will be able to penetrate the refrigerated vehicle market. And our road to get there is along 3 tracks. So we have already applied and utilized $40,000 of federal funding to create a proof of concept. This proof of concept is the foundation for our patent-protected technology and proves that the structural components of our panel work. The next step for us is to secure $400,000 of funding to continue our testing, creating both a small and large box prototype. At the conclusion of the small box test, we will have a proven process to manufacture the technology, as well as begin our accelerated life testing, which will tell us what the useful life of the panel is. At the end of the large box test, we will have proven scale to meet the market demand. At the same time that we're conducting this testing, we will pursue key strategic partnerships to drive and penetrate the market. The first one that I want to talk about in a little more detail is on the push side. So we have already spoken with Thermo King, who is one of the leaders in that particular space of the compressor manufacturers. And they have pledged that they will promote our product because we directly help them. We provide the benefits that Laura was speaking about earlier. By providing a more effective insulation for these refrigerated vehicles, we reduce the strain of the compressor, thereby reducing the liability cost to service overworked compressors. We have also spoken with the CFO from a refrigerated vehicle manufacturer in the Midwest, and he's very excited about this product and the potential the value that he can offer his customers. So the next step for us there is for our engineers to work with their engineers really to understand what the best way is to integrate the technology into their product. On the pull side of the equation then, we plan on utilizing relationships that we have with existing cold good manufacturers as well as some supply chain companies to educate them on the value of having climate control insulating their refrigerated vehicles. And the value is huge. It's over $85,000 of value that we can deliver their customers annually per trailer. And just to break this down a little bit, so the increased hauling capacity, so this is a couple of mock-ups here. This is a mock-up of what our product looks like, climate control. It's a 1/2 inch thick and has an R value of 50. This is about the thickness of the current polyurethane foam, and our R value is twice as good as this, so this is about 20. Now, if you take that and extend it to an entire 53-foot trailer, we can add almost 27% of hauling capacity to every trailer. That's like adding 900 cubic feet to a single trailer. And in context, that's about a small bedroom that's 10 foot by 10 foot with 9-foot ceilings. Now, given that increased hauling capacity, that's the equivalent of adding 1 trip for every 4. We were then able to obtain some financial models from a cold good manufacturer in Chicago, and we took their financial operating models and said, had we been able to add 73 trips through the increased hauling capacity, we would have saved them $70,000 annually to run those trucks. The other benefit that I wanted to talk about are these environmental regulations. So about a month ago, there was a company called General Produce here in California. They were fined in excess of $30,000 because their fleet was in violation of those environmental regulations. Had climate control been in the market for them, they would have avoided those fines. Our plan to deliver the technology to our customers is to implement kind of the Dell just-in-time model. So we will take our customer orders, give them to our suppliers, who will then give us the sub-assemblies. We'll bring those sub-assemblies in-house, put them together using our patent-protected technology, delivering a 1-foot square panel to our customers. So at a price of $4.25, that's just under $10,000 then to insulate one of the 53-foot refrigerated trailers. And that's priced competitively with the current polyurethane foam, which is between $10,000 to $12,000. And that ranges a little bit because they can vary the density and the thickness of that polyurethane to meet different R requirements. And so we understand that we're going to have a couple challenges or potholes along the road. And so to overcome patent publication, we plan on implementing first mover advantage to create brand equity, making climate control the VIP of choice for refrigerated vehicles. To overcome cost to manufacturers, we feel that we've priced this out that our customers will receive an ROI within the first year. And lastly, for durability, we've built a road to commercialization with options that in the event that another market becomes more attractive to us, we're going to be able to easily switch lanes and capitalize on that. Now to talk about more in detail about our finances, I'm going to turn over to James.
Thank you, Jacob. We're seeking $2.4 million in funding to be broken up into two stages. The first is $400,000 in exchange for preferred stock to help us get us through our small box prototype into our large box prototype. And then, upon completion of product development milestones, we're going to go after $2 million to help continue getting us to market. Now, as you can see, we look to be cash flow positive between 18 to 24 months after the initial investment. At that point in time, we'll have about $3 million in annual revenue. Now, with a 22% market growth rate, as Laura had mentioned, 15% market penetration, by year 5, we look to have close to $50 million in annual revenues. Now, our exit strategies. You can see here at certain inflection points along our growth, we have looked at our strategic partners may become interested in purchasing us. One, United Technologies and Ingersoll Rand, they're the parent companies of Carrier and Thermo King. Also, once we hit the $50 million mark, we believe that some of the insulation manufacturers may become interested in us. The second opportunity is for us to take these revenues, reinvest into our company, and manage the growth business and pay off our investors. Now, while sitting here, you may have thought of other applications for this technology. And you're right. We have as well. Warehouse storage, commercial and consumer refrigeration, data centers, even military applications. Anywhere where you need a temperature-controlled environment is a potential market for climate control. We chose refrigerated trailers for 3 reasons. First, economies of scale. There's a lot of fleets and there's a lot of diesel out there. 2, clear and impending market drivers, as Laura had mentioned, and advantages over the current technology. These 3 factors combine to give us a very strong foothold in the cold chain space. Now, you may also ask yourself, who's driving this truck? Our inventor, Dr. Alan Fireman, he has an equity stake in this venture and is committed to seeing us through to product development. He is actually in the front row here. He has ventured with us to San Diego for this challenge, so thank you for that. Our student management team here, we have 15 years of B2B purchasing and sales experience, 12 years of corporate customer acquisition and management, 12 years of manufacturing engineering experience, and 5 years of marketing patented products. As we move along our path to development, we look to add advisors and board members to complement this management team. But you can rest assured that we possess the necessary skill set to bring this technology to market. Now, to date, we've taken $40,000 in federal grant money, applied it to our proof of concept, and generated our patent in 2007. Now, as you can see, in 2009, TCT, the company, formed. We've been working together for 9 months on this project to advance the technology. Currently, to date, we have a license granted from the University of Illinois Chicago OTM, Office of Technology Management, to pursue and advance this technology. We have won close to $100,000 in cash and in-kind services to advance our technology. We have developed our product development path, our delivery model. We've spoken with potential customers. We have several meetings set up along those lines, and we've identified some suppliers. So, in closing, we're offering a 9x ROI for early-stage investors, and we are going to revolutionize the trucking industry. Lower fuel emissions, clean energy tax credits, and we're going to drastically reduce the cost of cold chain transportation. Thank you for your time, and we'll take your questions.
We will now be starting the 20-minute Q&A session. Each judge will be asking 1 question at a time with no follow-ups. Questions will begin with Jim Signal.
Is there any ability to convert trucks on this? Can you take it out and put it in a standard truck, as an example, so that you could go one-way refrigerated and one-way dry?
I hadn't thought about that. That's such a really good idea.
Like Costco trucks?
Yeah, I was going to say, that's a really good idea. I hadn't thought about that.
I'll try to come up with another one, okay?
You made me the first judge to win this contest.
Yeah.
We've looked at retrofitting the trucks, but we haven't looked at actually transitioning the trucks between refrigerated trucks and non-refrigerated trucks. But we have looked at the retrofit market.
Thank you.
Your market size just doubled.
Actually more so than that, because the number
no,
of trailers
just
that
teasing.
aren't refrigerated is significantly more than the reefer trailers. So
Okay, next.
So you're making them in one-by-one panels, or you can make them in larger panels. How do you actually put them in? How do they actually get manufactured into the vehicle?
Well, actually, no.
We know
What
how
you're seeing-
insulation works, but it's not clear to me how that one's going to.
Yeah, and these are mock-ups of our panels. The current technology, what they do is they actually build the trailer in place and then they foam in. Ours is going to be designed into the structure of the panel, and depending on the application, we've priced it out and brought a 1 by 1 foot mock-up because we figured it'd be easy for people to see. Ideally, we would like to do them as large as possible. We reduce the edge losses that way. We're able to use less framing material to put them in, and then we're able to design them into the trailer. So I'm sorry.
No, go ahead. Is it heavier?
Actually, there's a potential for a 200 to 400 pound weight increase based on the foam, based on the current technology. But if you're familiar with the trucking industry, there's idle reduction units. And there's actually a tax break and a weight allowance of 400 pounds for idle reduction units that are put in place. The idle reduction actually, it'll help run the cab and it'll help run the trailer. When they park at a truck stop at night, they still need to keep the driver amenities going. And that in the past that had used fuel close to a gallon an hour just to keep the driver comfortable. So now with these idle reduction units, they're able to take that down, and the Highway Transportation Authority has actually granted an allowance on the maximum weight so that they can put that in. So that's one of the things that we're going to pursue.
And you've done a lot of cost analysis around, how your product would save costs. But have you done the analysis around that additional weight, potential engine wear and tear, things of that nature?
Potential engine wear and tear, no. I'll say we haven't looked at that in terms, but
Did you say 200 to 400 pounds per trailer?
200 to 400 pounds per trailer, but the total maximum weight is 80,000 pounds. So you're talking potentially a 1% increase in that range. According to a model that we have from a cold good manufacturer, they're based in Chicago, and their products are actually in Costco. They get between the tractors themselves get between 6 to 8 miles per gallon, loaded or unloaded. So the amount of fuel burned, we're not sure that would be additional. But we haven't.
8?
Yeah, that's
6 to 8, not 68.
Yes, 6 to 8.
Oh, yeah. Good.
Yeah. If I can get a tractor to go 68, we're gonna make a lot of money. We got a whole different plan for that, but no, 6 to 8 miles to gallon, loaded or unloaded. From what I was told from a logistics manager, he said that the fuel consumption wouldn't be necessarily the same. From that, we may be able to say the engine wear and tear, but that's something we'll definitely have to look at once we get to our large box test, our road test. Along our path to commercialization, we have our proof of concept, we have small box, large box, and then we have road test. The small box gives us more data on our process. The large box lets us scale it up and test it at a smaller scale before we go and build a full-scale prototype. At that point in time, we'll be able to have those measurables on both the tractor and the trailer.
Thank you.
So tell me, did you say you're charging $10,000 per truck? Is that your price? How does that compare with the foam?
yes, the foam is between 10 and 12,000 right now, so it's comparably priced. And that varies based on the density, thickness, and potential other agents that they add to the polyurethane as they're constructing it.
So you're selling a lot of steel there too, right? The question I have is how do you you're showing 80% gross profits. Is that true?
Jacob?
Yeah, I think so. Yeah.
Yeah?
Well, actually, I'm not sure. I think the plan that we submitted that you're looking at potentially could be one that was an earlier version. So we have since switched from a licensing model to an assembly. So we're not at the same rate.
Not at the same GPU?
Right.
Yeah.
I also want to add to your question in comparing the polyurethane foam. What happens with the foam is that it degasses over time and it actually loses that R value. So it actually gets more expensive to insulate the truck over time with that polyurethane.
No, I understand the benefit. I'm just trying to get to what the business model is. What are you selling? So are you selling the panels or?
Right, selling-
Yes, we will be supplying the panels to the trailer manufacturers, or the panel system, if you will.
If you didn't put your special sauce in it, how much just the steel cost?
How much of the cost is just steel?
I think it's about $1, just a little over $1.
Yeah,
Square foot.
our cost per square foot of panel steel is a little over $1.
And you're selling it for? Okay.
Now, our cost model is built in to accept some of the fluctuations in the market because we've got, there are several components that are going into the panel assembly, Kevlar, a vacuum insulation getter, forming of the metal. And so currently we've priced it so that we're comparable to the foam and that we've got room to accept market fluctuations within our product, within our raw materials.
Should we go, okay. My question is kind of targeted more at kind of your sales cycle or your adoption rate. So my question actually is for Jim. If you were to sell this to Costco, how long would it take to get products like this approved, either to be installed in your warehouse or in your trucks? What would these guys have to go through to get you guys to buy this product? That's for you. Yeah. I'm trying to sell their
I
product.
make one simple comment, and all of a sudden I'm
Yeah.
on the defensive.
We'll take it.
Well, obviously, we would want to see a test. We would want to know that we were getting greater capacity. Capacity for those trucks is a very important issue because they run long mileage. So to the extent that you can improve capacity by 5 or 6%, that's very significant when you're making runs from California to Arizona, as an example. So we'd want to see the tests. We'd want to know that we could indeed get greater capacity on there and that it was going to not increase our fuel usage.
We actually spoke with Midwest Utility, who's one of the, or Utility is one of the leaders in that space, and they told us it's about a 9-month road test cycle to prove out a new technology in their trailers. So that's why we've built a model of 9 months.
So about 9 months? So
About 9 months to, yeah. Once you have
Okay.
the prototype in an actual truck, about 9 months of road testing to ensure that it's going to meet the structural
Okay.
components, safety standards, highway standards. And that was
Great.
based that was based on a conversation with Utility. So.
Yeah. I would just add to what you said and the importance of the hauling capacity. We spoke also with Utility, and they told us a story of how they lost over a $1 million deal because they weren't able to meet the R value that their customer needed with the certain inches of polyurethane foam. So they weren't able to get a thinner foam but achieve that same R value. So they lost over a $1 million deal based on about 1/8 of an inch of insulation because they needed that hauling capacity. So that's huge. It's a huge need in this industry to increase the hauling capacity per truck.
It all comes down to, all of these things relative to the environment come down to commercial value and
Okay.
whether or not it's going to pay off in the final analysis. And that would be the big measurement. The big measurement would be, you're now running 1,000 trucks to Colorado. Can you cut that down to 950 trucks?
Okay.
Yeah.
That's right.
And you're also
Yeah.
decreasing your cost per truck with that operating cost on the fuel and the
Sure.
maintenance.
Okay, and the reason I asked him that question is, in your sales assumptions, you think you're going to make, you're going to be penetrated 5% of the market within 18 months, and that you'll be profitable year one?
Yeah, at the end of year 2. Yeah.
Pardon?
It's at end of year 2, turning a profit. I think the
I think you said, yeah, well, whatever.
In 18 months. we
right,
said.
in 18
Okay,
months.
do you want to talk about that? I mean, that's, you know, you're getting into the market really quick, and you're ramping sales, and things are cranking, and can you explain how that's all going to happen?
Sure.
So we've based that on the
In light
market.
of the fact that it probably takes you 9 months to maybe get into an account?
Well, okay, so we've actually, we've modeled some of this penetration adoption rate based on 2 things. One, some of the tire pressure gauges, as well as the single tire. So going from the double tire to single tire. Where those applications have been successful, the adoption has been very, very quick in the marketplace. So on the tanker trucks, which is a different type of trailer, they've gone from the 2 tires to single tire,
Single-wide.
a single wide tire, and that's
It increases the efficiency of the vehicle.
yeah, no, yeah. So that's so, and that because it was so good at it, at reducing the cost, it was adopted very, very quickly.
Yeah,
So
within the first year, there was like a 90% adoption rate. We spoke with a trucking a research trucking transportation firm, and they gave us that
Okay.
information.
I have just one more quick question. Tell me about your sales team. How are you going to get in the market? How many sales reps do you need? How are you going to sell this thing? How is this all going to come together?
Well, our initial plans there are we've got one conversation with one of the smaller players. So I think our strategy is to really focus on one or two of the smaller,
straight trucks.
the straight trucks to get adoption to prove that the technology works. Once we get done with that, then it's moving on to the larger players. And since there are fewer players in that space, our plan really was to bring in kind of a C-class level executive that could help us really drive that because it's a really big, it's a B2B business sales model. So we were.
So how many sales reps are you going to need? And how much business are they each going to do? I mean, how are you going to get into these accounts and get these things closed, make these transactions happen?
That's something that we're still looking into, that we have to look into further.
Okay.
How many salespeople and whatnot. I guess right now we're still working on our back end stuff of working out the technology and how we can best deliver the technology to our customers. And then we'll.
Yeah, and I was kind of more focused on your sales organization, but you're going to get to that eventually.
Okay, yeah, that's definitely something that we are going to need to focus on. Thank you.
Great, thank you.
But something else for us to look at along those lines, we've broken out the market segmentation, and we've got fairly few players in the market there. Our view is to go after one person initially, go after one market, one of these markets and one of these manufacturers initially, and get that person closed out. There may be the option for exclusivity there, depending on the model. And then from that, we'll move forward to different players within the market. So we may be able to do it, just in thinking now out loud, we may be able to do it with one or two sales reps to help us go hit these companies and work very hard with them.
Great, thank you.
First of all, I'd like to say that it's obvious that you've practiced this a lot and rehearsed it and really did your homework. So brilliant job on that. Thank you very much.
Thank you, sir.
The question I have is, it has to deal with, in line with a lot of the other questions, is supply chain and standardization. Although you have extra room in the truck now, a few inches here, a few inches here, and if you extrapolate that out, you say that's X, Y amount of additional capacity that you can haul. However, if you look at the whole supply chain as far as the size of skids and pallets and the whole inventory methodology, it's all automated now. Have you factored that into your equation? Because it seems to me you're not fitting a whole extra skid or a whole half a row of a skid. How do you get that extra capacity in the truck?
If I may, sir, I work for a major food manufacturer, and I'm one of the engineers there. And I've actually been through the packaging lab. We redesigned a meat packaging container to shave 1/4 of an ounce off so that we could get more cube per truck. So in talking with the packaging engineers, if we can deliver more capacity in a trailer, they will do what they can to get more items in there because it just drastically reduces the cost. Pennies per mile becomes a very important metric in logistics. And so we believe that if we're able to deliver that, the food companies will then take the next step and make some of the changes necessary to take advantage of that.
Because that's a Herculean event to change the standard of those skids and that truck. So I'm glad you're thinking about that. Yeah. Then another quick question, and very simplistic. I'm a pretty simple guy. If you had two boxes here, one with your material and one with the other material, and you put a big chunk of ice in the middle, shut it down, are you telling me that if we opened it up, however many later, you'd have twice as much ice left in your product?
If I may.
Yeah.
This is a. Forgive me. May I approach the stand, Your Honor?
Sure. Yeah.
Thank you. This is a vacuum thermos. Okay. Vacuum insulation has been around for quite some time. Now, if you pour your cup of coffee in the morning, which is going to stay warmer, this or this? Yeah. The technology is proven on the market. It's available in a lot of different ways. We have a better mousetrap.
Okay.
And that's what we're bringing to market.
And inside that vacuum, do you ever anticipate putting any gases inside there? For instance, there's a lot of technology out there that, depending on the gas that's inside, like a double pane window, this is basically what it is, right? A double pane window.
You're speaking of the noble gas technology where they use a noble gas as an insulator. We're actually going to pull this down to a 10 to the minus 5 torr. One of the things that we can do, by pulling down that low, you eliminate the heat transfer by convection. And that's one of the things, if I can, the way our panel works, where is it? Uh-oh, please get that. The way our panel works is that we address the 3 modes of heat transfer, okay? No, not that one. I can talk to it. There's conduction, convection, and black body radiation, okay? Conduction is you put coffee in a coffee cup and the outside of the cup gets hot. Heat's transferred right through. We've extended the thermal path by using the filaments and tension, and so that takes away that route. Now, convection is airflow. By pulling a vacuum inside of that, we remove the opportunity for that air to flow, and we remove the opportunity for heat to transfer in that mechanism. And then radiation, sun on the sidewalk. You guys got plenty of sun here in San Diego, right? So we're able to block that with black body radiation shields, and that keeps us cool. So we've addressed all three forms. We have thermal models based on current engineering principles that are used every day in thermodynamics. They're taught in undergraduate. We use those to build our panel. That's what the science is based on.
Okay, great. Thank you.
You know, you mentioned the deterioration of the foam. Are there any other aspects of your product that makes it more durable than the foam?
We actually have a vacuum sensor inside of ours. One thing about the foam is that it begins to deteriorate. Actually, when we called and did some research, they quoted me two values. They quoted me the value when it's first cured, and they said the final value. So they said, oh, it's got an R value of 6 point something, but by the time you're using it, it's probably down to 5. And Thermo King, who's a supplier, they've actually come up with a product to address this, even though the foam outgasses. They lose effectiveness over time. Our patent covers a vacuum insulation sensor, or a vacuum sensor inside of our panel. So if that sensor, the sensor goes off, it tells you that we've lost the vacuum in the panel, which will cause us to lose insulation effectiveness. We can replace that panel. It's going to be kind of like a spare part model where if a trailer is purchased, yes, it's a modular design inside the panel. If a trailer is purchased and you find that, hey, the sensor has gone off and the panel has defaulted, pull it out, put a new one in there, your trailer is back to normal.
But I was referring more to wear and tear. I mean, you have load shifts and you know, you've got trucks and forklifts that are loading these trailers. Is there any performance criteria that makes your product as good or better than the foam?
You're talking about puncture resistance and, well, currently we're going to use it inside the same, essentially the same plastic walls that are used currently. Now, as we progress into our prototype stage, we may find that we may need something else to cover that, but we're taking that up with our engineering and our development teams.
How we can improve that. James, I just want to reiterate what James is saying. The current polyurethane foam is encased in like a lamination panel, 2 panels of lamination. So our panel will be then encased and supported. It's an extra layer of support, you know, because, you know, pallets do get pushed into the trucks. It's an extra layer of support for the panel.
So there may need to be some additional rigid materials that are designed into the trailer to help support where some of the foam may have been, but otherwise I think we'll be on the same footing with them.
Thank you.
Have you looked at commodity prices for the stainless steel historically or into the future in terms of your cost of goods?
When we did our research, we received several quotes, but we did not go back through the economic price fluctuations of stainless steel. We actually put in some margin just to cover that. As we get closer to our prototype stage, that is definitely a pricing model that we're going to take in to our manufacturing model.
Also, we did look into the price volatility of Kevlar because they project that Kevlar might go up in pricing. And there's another, I don't know if you're familiar with that material, it's called Nomax. It's similar to Kevlar, so it wouldn't give us the same R value. So maybe that's something that we're looking at down the road to have, you know, our premium panel with a 50 R value, but then we could maybe have a less expensive panel that maybe would give us an R value of about 25. So it would be, you know, a new product that we could roll out down the road.
And what are your barriers for entry in terms of this product? I mean, it sounds phenomenal, but are you, what risks do you see out there in terms of it not getting adopted?
So the 3 risks that we see really are the patent publication. And so to get over that, what we're hoping to use that first mover advantage, creating brand equity, making it just the VIP of choice. So the cost is another thing. And so we think that we've priced it in such a way that our customers will receive a return on their investment within the first year. And then the other third one we see is durability of the panel that you spoke about earlier. And so our plan there is we've developed a road to commercialization that has options. So in the event that another market becomes more attractive than refrigerated trailers, we can easily switch and go to a different product, go to a different market.
That's one of the reasons we love this technology, because there is so much potential for insulation and there are so many applications. This is just one, refrigerated trucking is one, and down the road we can look into more.
Our patent also covers clear vacuum insulation panels. Can you imagine saving the cost on a large building? because you're able to have a window with a higher R value. So there's a lot of applications that we have.
Okay, well, that concludes our time for the Q&A session. I'd like to thank our judges for excellent questions, and I'd like to congratulate the team on an excellent presentation.